Good evening, or afternoon, or morning, or whenever you're watching this. Um, this is section 4.1, and it's all about relationships and graphs. So we're starting off section 4, or chapter 4, which is all about functions, and we're talking about graphs, because graphs are a big part of functions. So the goal that you should have written down again on your goal sheet right away is right here. So pause it if you need to. I can represent mathematical relationships using graphs. All right? Couple words you got to know. First one is the x-axis. Hopefully you remember on an x-axis on a graph. I just have a small chunk of it right here. Ooh, I actually made them the wrong colors. That is embarrassing. I'm going to change that. If you look over to the right, if you remember the x and the y-axis, the x-axis is the horizontal axis. Horizontal means going left to right, like the horizon. All right. The way that I think of it as is whenever you sign something, I don't know if you have to sign a check or sign a document, they always say sign at the X. That goes left to right. Okay? That's right here. That's the left to right axis. The vertical axis is the Y axis. Um, I don't know if you want to remember it as it's the taller of the two letters. Y is a taller letter. Um, you go in an elevator before you go up, so X goes before Y. X would be going in an elevator, and Y would be going up. That's another way to remember it. But those are the X and Y axes. So we're going to use some things with those axes, and we're going to start off by talking about how to analyze a graph. So I'm going to give you a problem like this. This problem says the graph shows the volume of air in a balloon, so how much is inside of a balloon, as you blow it up until it pops. What are the variables? Describe how the variables are related at various points on the graph. So, the answer is given here. It says the variables are volume and time. So hopefully, if you look at it, you can figure out the things that are changing. The volume is changing and the time is changing. And if you look at the graph, it has a label, a title too. You should always have a title. As the time gets higher, so it starts at 0 and it goes higher, maybe this is up to 10 minutes, whatever it is. The volume of the balloon, it kind of says here, is getting bigger. It's like you blew it up, taking a breath in, blew it up, taking a breath in, blew it up, taking a breath in, blew it up, taking another breath, started blowing it up until pop, and the volume goes back down to 0. That's what the graph of it looks like. It's described over here on the left as, so we have the variables are volume and time. The volume increases each time you blow and stays constant each time you pause to breathe. When the balloon pops in the middle of the fourth blow, so one, two, so this would be 1, 2, 3, 4, the volume decreases to 0. Okay, so if we're looking at this, how do we label or how do we analyze the graph? How do we look at the graph and analyze it and describe it? Well, I only have two steps here for you. Look at the title and labels. So if you're just looking at the graph, dealing with air in a balloon, and the labels for the axes were time and volume. Those are your variables. Not sure how that happened there. Variables. Okay? And you can kind of figure out as time goes up, the volume goes up until it pops. So then step 2 is observe how the graph changes as the quantities on each axis change. So what I was saying there is, how does the graph change when time goes up? Like, how does the volume change when time goes up and vice versa? So why don't you try this one on your own? Well, maybe I'll do one of them. You can do the other one. Um, Using those procedures, what are the variables in each graph? Describe how the variables are related at various points in the graph. So I'll do the first one, and you're going to have to do the second one on your own. First one says, what? Whoops. First one says, we're dealing with board length. So whatever kind of board we're dealing with, length of the board over time. So our variables are, this is annoying, our time and length, and that would be length of the board. because we're given time and length right there. If I were to describe how the variables are related at various points on the graph, I would say as time goes on, there are moments where the length of the board stays the same, and then it looks like we cut off a chunk. Every time we have right there, right there, right there, the board length is getting smaller. Just right away, it's just going, no time is taking, it's just going smaller. So it looks like at those spots, those three spots, I would have to say that the board is probably being cut. So to describe it, I would say as time goes on, there are three different spurts where the board gets drastically or cut shorter until it goes on. There's still some length left. It's not down to zero, but the board is getting every once in a while, every I don't know increment there, it's getting cut shorter. So I want you to look at this one, B, and in June, this is the June cell phone cost. Figure out what the variables are and describe how the variables are related at various points on the graph. Okay? All right. Hopefully you did well with those. Analyzing a graph. Again, here's another example. I'm going to give you some multiple choice. First one I'll do with you. Second one you're going to do on your own. So we're going to match a table with a graph. So this time we have a table. We'll be dealing with lots of tables this chapter. So there's our table. It says a band allowed fans to download its new video from its website. The table shows the total number of downloads after 1, 2, 3, and 4 days. Which graph could represent the data shown in the table? Well, if we look at it, looks like it starts after day 1, they're at 346 downloads. Day 2, they're up over 1,000, so they almost multiplied by 3. Um, or added 7,000 there. Day 3, holy cow, it tripled again, added like over 2,000. And then again from day 3 to day 4, it goes up by about 7,000. So it's definitely not consistent. The days are consistent, but this part is not. This is up 700. This is up 2,000-ish. And this is up 7,000-ish. So if we look at it, it's not going to just be consistent. So I'm going to say no to this one and no to this one because it's definitely, as the days go on, the downloads are not going down. So that's why this one's out. Um, C, it looks like they're still going up, but they're not going up by as much. And B looks like each day they're going up more and more. This is a one increment. This is a more increment, even higher increment. So I'm going to go with part B because if you look at the table, each day it's getting more and more for that day. So why don't you look at this one right here? And number 2 says the table shows the amount of sunscreen left in a can based on the number of times the sunscreen has been used. Which graph could represent the data shown in the table? So we're given our table of sunscreen, however many times using it, and how much sunscreen is left in the tube. And I want you to figure out which one of those graphs goes best. Caw, caw, caw! That was my crow. I found a picture of a crow, and crows are kind of scary birds, but there you go. There's your crow. Hopefully you're awake and watching the video. Um, if you watched the video and you heard me make that crow sound, you should come to class tomorrow and make the crow sound, and I'll give you a piece of candy. All right, but moving on. The last thing I want to do is sketching a graph. So how do you sketch a graph? So this is a problem that you'll be given. It says a model rocket rises quickly, then slows to a stop, and actually I'm going to cover this up. Um, as it burns out. It begins to fall quickly until the parachute opens, after which it falls slowly back to Earth. What sketch of a graph could represent the height of the rocket during its flight and label each section. So the things that are changing, I think, would be the time over time, and then the height of the rocket. So here's a graph that would work for this. Um, Time, we are dealing with time. That's one variable, and height. So this graph was just drawn. It's not a perfect graph. Again, it has a title, Model Rocket Flight. But you're looking for, it says it rises quickly. So it looks like at the front part, it did rise quickly. It went up pretty quick. Then it slows down to a stop as the fuel burns out. So it stops right here. It's actually going flat then. Then it begins to fall quickly. Here's a quick fall until the parachute comes out, when it then falls slowly back down to Earth until the ground. So then it just goes slowly down. And that's exactly how you make a graph. It does not have to be perfect as long as you can label and show those clear different moments in time that are described in the problem. So a good way to give you a procedure for this, if you're graphing, this is a procedure for sketching a graph. So first identify the variables that are being compared. And I said that right away. We're going to compare time and height. All right, and then label this. So that's going to be on the labels. Look for key describing words such as rises quickly or falls slowly, and I actually underline them all. That would be a good thing to do. I'll even put that in there. Underline them. Those are going to be all where it changes, where the graph changes. Then make your coordinate plane with the title and label. So the title again is on top. We have our labels of our axes. And then finally, use those key describing words to graph the line or curves, lines or curves on the graph. All right? So I've got one more example here, and we'll go through this one together. Number 3, it says, suppose you started to swing yourself on a playground swing. You move back and forth and swing higher in the air. Then you slowly swing to a stop. What sketch of a graph could represent how your height from the ground might change over time? So it looks like we're having time and height again. So I'm going to make a graph here. We'll do time over here, and we'll do height over here. And my label, I think I'm just going to say swinging height. So I kind of went out of order. Look for the variables that are being compared. Well, we did that. Time and height. Those are our variables. Then look for key describing words. So let's look in here. Suppose you start to swing yourself. You move back and forth and swing higher in the air. So you started, and then you started getting higher and higher. Then you slowly swing to a stop. And we want to represent the height. So it looks like you're starting at 0. And the thing about that is your height, as you're swinging, you swing forward, you go up high, and then you swing back, and you go back down, and then you swing up high in the back as well. So you do go up and down a lot. So I'm going to say you swing up a little bit and go back down to almost 0. Swing up a little bit, go back down to almost 0. Then you swing it up really high, you're getting higher and higher, but you're always going back down to that spot. And then it says you slowly start going slower and lower, and then you come to a stop. So that's my graph. And again, the reason being is because when you're swinging, these would all be the parts where you're going back down to the ground. Because you swing forward and go back down, swing back and go back down. These are going to be your highest points as you're getting higher and higher and higher, then you slow down and get lower and lower and lower. All right, so that's my graph. Part B says if you jump from the swing instead of slowing swing to the stop, how would the graph in part B be different? Well, I would think once you got to your highest point, you'd actually go up, 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 and then you'd actually get back down. So that's what that would look like, I think. So that is section 4.1. I do have one closing question for you to think about. It says, describe a real-world relationship that could be represented by the graph sketched above. So you're going to answer a question on that. And again, remember, caw, caw, and there's your goal. So hopefully you learned something today. We'll see you next time.